Hello, everybody. Welcome to Section 4, Chapter 3 of the Algebra course hosted by Iridium Tutoring. Section 4 is on the elimination method. As you know, so far in Chapter 3, we have been learning about systems of equations. Last video, we learned how to solve systems of equations using algebra, aka substitution. This video will be continuing with another method we can use to solve systems of equations using algebra. Two-variable elimination method. The elimination method solves for variables by performing addition or subtraction of the respective equations to cancel one of the variables out so that only one variable is present. Here's an example. Given the two systems x plus y equals 20 and 2x plus 3y equals 45, solve them using the elimination method. So the elimination method focuses on canceling out certain variables completely so that you can solve for one variable, hence the word elimination. So what we could do is in this set, what we could do is first identify which variables we want to cancel out first. So in this case, let's just cancel out x. So to cancel out x, we have to look at the other system and see what differences we have here in these two guys. So as you can see, the second system is 2 times x, whereas the first system is just 1 times x. So what we can do is just multiply the entire system. So remember, whenever you're multiplying to cancel out, you have to multiply it by the entire system, not just the variable. So we have to multiply this entire system by -2 to get minus 2x minus 2y equals minus 40. Because if I solve it up here, all that it's doing is using the distributive property to solve it. So 2 times x plus y equals 20. So -2 times x would be -2x. -2 times y would be minus 2y. And then the equal sign, and then -2 times 20 is -40. Hence this equation right here. Okay, so once we get that equation, you can see that both of these coefficients have been set up perfectly to sort of cancel them out. So in this case, what you can do is add addition, add the two systems to cancel these variables, cancel the x variable out. But let's just say I multiplied it by +2 instead. Then I would have 2x plus 2y equals 40. And then the other system would be 2x plus 3y equals 45. In this case, you wouldn't necessarily add them to cancel them out, because if you add them, then 2 plus 2 is just 4x. In this case, you would subtract the two systems. So you would do 2 minus 2 to cancel that out. And you would do 2y minus 3y. So you would end up with minus y. Yeah, minus y equals 5. And then you would just get y equals -5. So you can also do it that way as well. So yeah, you just, once you cancel them out, those are out of the equation, then you're just left with this part of the equation as portrayed right here. So what you would do is that you would still use addition, because we're keeping the flow, continuing everything perfectly. So you have to add minus 2y to 3y, which would be just y. and then you would do minus 40 plus 45, which is just 5. So y equals 5. And now we do it the same way for the substitution method. You would just go back to either one of these systems and plug y for 5 into any of those to find x. So let's just take this one first, and then we'll also do it the other way as well, just to see that it should work. So 2x plus 3 times 5, remember we know what y is, so we can just substitute y for 5. 3 times 5 equals 45. So do 3 times 5, which is 15. So it would be 2x plus 15 equals 45. And then subtract both sides by 15 to get 2x equals 30, as seen right there. And then divide by 2 to get x equals 15. Now let's go to the second equation. Let's test that out as well. So just not knowing what x is, x plus y, remember, and we know that y is 5, so substitute y for 5. X plus 5 equals 20. Subtract both sides by 5 to get x equals 15. So both ways work, and that is how you do the elimination method. Here are some practice problems. I want you to pause this video, work through each of them, and solve them for its x equals y equals. And to the right here, if you have time, here is a challenge problem. Basically what you have to do is look at these lines, figure out the equations for the lines, and then solve them. So it has multiple different steps, and it's a pretty neat challenge problem. All right, here are the answers to the first three. We can also use the elimination method to 2 plus variable systems. In 2 plus variable systems, you usually have 2 or more systems of equations, as seen here. So like eliminating with 2 variables, you add and subtract each equation to solve. However, we also pair certain equations together to eliminate variables. I would just like to remind you, this is a very, very brief introduction to 3 systems of equation solving. We will go over that more in our Algebra 2 course that goes in depth with many of the algebra topics. So given these 3 systems, which have been neatly color-coded here for simplicity, x minus 3y plus 3z equals negative 4, 2x plus 3y minus z equals 15, and 4x minus 3y minus z equals 19. So as mentioned up above, we have to make different pairs of equations to solve this. So we have to break these 3 down into 2 different systems. So let's take the first equation and the second equation. What we can do here is just cancel out any correlating variables. So minus 3y plus 3y, we can cancel those out. And then you're left with the equation. And remember, we are adding this. So you are left with the equation. So x plus 2x, 3x, and then these cancel out. And 3z minus z. So it would be 3x plus 2z, and then minus 4 plus 15, which is just 11. And this equation has been color-coded in orange, so remember that. And now we also have to find the second pair so that we can have our second system of equation so that we can solve for one variable. So what we did here is take this green one and this yellow one and set them up so that we could cancel them and solve them. So we are again adding these 2 systems of equations. So it would be 2x plus 4x, which is 6x. And in this case, we're just canceling out y so that we have a system with only 2 variables. And you have to remember that these two variables are similar to the first pair of variables. Hence, x and z we kept, and y we just tossed out for now. And then minus z plus minus z, which is just minus 2z, and then 15 plus 19, which is 34. And this system, or this equation, is color-coded in dark blue. So now that we have these two systems of equations, we can use the elimination method to solve for it. So you set them up, and remember we're adding because we have positive 2z and negative 2z. So if we just add these two, they should cancel out. But if you subtract them, it won't work because it'll just end up being 2z plus 2z, and that doesn't work because we want to eliminate an entire variable out so that we can find x. So 3x plus 6x is 9x, and then 11 plus 34 is 45. So 9x equals 45. Divide both sides by 9 to get x equals 5. So now that you know that x equals 5, you go back to either one of these pairs to find z, or any other variable if you're solving another problem. So in this case, we took the orange one for simplicity's sake. So 3 times 5, remember, x is 5, so we can plug in x for 5. 3 times 5 plus 2z equals 11. And then, so this would be 15 plus 2z equals 11. Then you would subtract both sides by 15 to get 2z equals negative 4. Divide both sides by 2 to get z equals negative 2, as seen right here. And now you know what your x and z are. So what you can do is go back to any random one of these original 3 variable systems and plug in these new x and z so that you can find y, because y is the only variable that will remain after you substitute x and z in. So in this case, we took the green system right here and plugged in x and z into it. So remember, x is 5, so 2 times 5 plus 3y, which is the unknown, minus, remember, minus right here, minus, this is technically supposed to be 1, so minus 1 times minus 2 equals 15, because we know that z is minus 2. So what you do now is 5 times 2, 10, plus 3y, and then minus minus cancel out, so that would become positive, plus 2 equals 15. Then combine like terms to get 12 plus 3y equals 15. Let me just erase this so that I can, there we go. So now you would subtract both sides by 12 to get 3y equals 3, and divide both sides by 3 to get y equals 1. That is the answer to the 3 systems, and you would write them kind of combined with each other, near each other, because most likely when you're solving 3 systems of equations, your answers will be all over the place. So be sure to stay clear and concise when doing everything, as I'm doing right now. So keep all the answers together and circle the answer for your teacher. Here are some practice problems. You can pause the video and work through them. All right, great. Here are the answers for them. I hope you enjoyed the elimination method. Please tune in for our next video, which is on word problems using systems of equations. And that will be the last video for our Unit 3, Systems of Equations. I hope you enjoyed this video. See you later. Bye.